Imagine a game that knows you better than you know yourself, one that senses your frustration and eases off, or spots your mastery and throws in a new twist. This isn't science fiction. It's the cutting edge of game design, where artificial intelligence is reshaping how we experience challenge and progression. Welcome to the world of adaptive difficulty in games. But first, what exactly is adaptive difficulty at its core? It's a system designed to keep players in that sweet spot psychologists call the flow state, where the challenge matches your skill level just right. It's not too easy, not too hard, but just right, like Goldilocks if she were really into speedrunning. Traditionally, games have relied on static difficulty settings. You know the drill: easy, medium, hard, maybe a nightmare mode if the developers were feeling spicy. But these preset difficulties are a one-size-fits-all approach in a world where player skills vary wildly. Enter dynamic difficulty adjustment, where AI takes the wheel and tweaks the game in real time based on your performance. So how does AI learn your skill level? It's all about player modeling and telemetry data. The game is constantly watching you, analyzing your every move. How accurate are your shots? How quickly do you complete levels? How often do you die? All of this data feeds into sophisticated machine learning models that build a profile of your playstyle and skill. But it goes beyond just crunching numbers. Modern AI systems use reinforcement learning and predictive analytics to anticipate how you'll react to changes. It's like having a hyper-intelligent dungeon master who's always one step ahead, crafting the perfect challenge for you specifically. Let's look at some real-world examples to see this in action. Valve's Left 4 Dead series pioneered adaptive difficulty with its AI director. This system doesn't just spawn zombies randomly, it orchestrates the entire experience, controlling the pacing of enemy encounters based on how well your team is performing. Having a rough time? It might ease up on the special infected. Steam rolling through? Prepare for a tank to ruin your day. For a more recent example, look at Dead Cells. This roguelike uses procedural generation to create its levels, but it goes a step further by scaling the difficulty based on your past performances. The more you play, the more it learns about your capabilities, ensuring that each run feels challenging but achievable. But how do these systems know when to ramp up or tone down the challenge? It all comes down to metrics and triggers. Developers set engagement and frustration thresholds based on extensive playtesting and data analysis. The goal is to keep you in that flow state we mentioned earlier, engaged enough to feel challenged, but not so frustrated that you want to rage quit. These systems might track things like your heart rate variability, if you're using certain controllers, your input patterns, or even your facial expressions if you're streaming. When it detects signs of disengagement or excessive frustration, it can dial things back. Conversely, if you're breezing through content, it might throw in some curveballs to keep you on your toes. The benefits of adaptive difficulty are huge for both players and developers. For players, it means a more personalized, accessible experience. No more feeling like you're banging your head against a wall on a too hard boss, or getting bored because the game is a cakewalk. For developers, it's a powerful tool for player retention. By keeping the challenge just right, they can reduce churn in hardcore titles and keep players engaged for longer. But how do you actually implement something like this? Well, it's not exactly plug and play. Modern game engines like Unity and Unreal offer integrations with machine learning frameworks like TensorFlow and PyTorch. This allows developers to train and deploy AI models directly within their games. The real challenge is in setting up the data pipelines and adjustment loops. You need systems that can collect player data, process it, make decisions, and adjust the game state all in real time without noticeable lag. It's a complex dance of data and code that requires some serious optimization. Now, here's where things get a bit tricky. How much should players know about these systems? There's a delicate balance between transparency and maintaining the illusion of a seamless experience. Some argue that players should be fully aware when AI is adjusting difficulty to build trust and avoid feelings of manipulation. Others worry that too much transparency might break immersion or lead to players trying to game the system. One common pitfall to avoid is the dreaded rubber banding effect. where the game becomes obviously easier or harder in a way that feels unfair. Nobody likes feeling like the game is holding their hand too much, or suddenly cranking up the difficulty just because they were doing well. This leads us to some thorny ethical questions. Should players always be told that difficulty is being adjusted by AI? There's a potential for these systems to be used in ways that border on manipulation or addiction engineering. If a game can perfectly calibrate itself to keep you playing just one more level, is that a good thing? Or are we opening a Pandora's box of hyper-engaging experiences that are hard to put down? Looking to the future, we're likely to see even more sophisticated adaptive systems. Imagine cross-game engines that learn your skills across multiple titles, or cloud-based difficulty services that can instantly tailor any game to your preferences. We might even see AI that can craft entirely custom levels on demand, ensuring that no two players have quite the same experience. As we've seen, adaptive difficulty powered by AI is reshaping how we think about challenging games. It's a technology that promises more engaging, accessible experiences for players of all skill levels, but like any powerful tool, it comes with responsibilities and ethical considerations. The next time you're playing a game and it feels like it's reading your mind, adjusting perfectly to your skill level, well, it just might be. And whether that excites you or unnerves you probably says a lot about how you view the role of AI in gaming's future. Until next time, keep playing, keep learning, and who knows, maybe the games will learn something from you too. Thanks for watching, and don't forget to like and subscribe. If you want to see more deep dives into the technology shaping the future of gaming, see you in the next video.